Hi, and welcome back. We are going to install all prerequisites and dependencies to start developing a React Native application. First of all, you will need a Mac to develop React Native apps. At the time of this recording, other platforms aren't supported yet. You will also need Apple's IDE, Xcode, with version 6.3 at the least. I recommend, though, that you always keep your Xcode up to date, so you always have support for the latest iOS version, screen sizes, and bug fixes. You can get Xcode for free on the Mac App Store. Next is an optional tool I highly recommend. It's Homebrew. Homebrew is a package manager for the Mac, which lets you install software packages you might need in development, like a database server or some development libraries, in a heartbeat. We also need Node.js, since most of the tooling of React Native depends on it. We are going to do this through Homebrew in a minute. I will also install Watchman. It is another Facebook project which offers a platform-independent file watcher. It is not strictly needed, but prevents you from running into Node.js file watching bugs. Now that we know what we need to install, we actually have to do it. Let's hop into the terminal and install Homebrew. It offers a single line installation, which you can copy from the homepage. I already have Homebrew installed, so I won't run the command, but it is a very straightforward installation process. Next up is Node Version Manager. It lets you install multiple versions of Node.js. We are going to install it by typing brew install nvm. As you can see on screen, Homebrew gives you instruction on how to configure your installed package. In our case, we have to append a few lines to our bash profile file. In my case, that is .bashrc, but you might want to put it in bash profile or .cshrc if you are using CSH, for instance. I'm also going to paste those lines into the shell itself, so I won't have to reload my shell to make use of nvm. Now we can install the latest Node.js version by just typing nvm install node. I'm also going to run nvm alias default node to automatically use it by default. I also want to install Watchman and can do this with Homebrew. All that is left to do now is to install the React Native command line tool. We can do that by installing it globally through npm. Now that everything is installed, let's initialize our first React Native project. You can do this by running React Native init and then the project name. In our case, Hello World. The tool also gives you instructions on how to run your project in the iOS or Android simulator. Let's open the Xcode project to run our application. Don't worry, we don't really need to interact with Xcode, we just have to run the simulator. We can do that by hitting the play button. Xcode will compile the iOS app and launch the React packager, which is responsible for compiling and building the React Native app and providing it for our iOS wrapper. I use the iPhone 6s here, which is far too large for this screen size. So I scaled it down to 50%. Welcome to your first React Native application. Whenever you make changes, you can refresh the page with Command R, and you can also see the reload on the left side as an HTTP request. When you press Command D, you can bring up the developer menu, which gives you a lot of options to play with. You can, for instance, debug your content in the Chrome Developer Tools and Safari Web Inspector. But we are going to look at this in a later lesson. You can also manually refresh or enable auto reload, as well as use even more debugging tools. Let me put the simulator on the right side of the screen and bring up my editor on the left. Now let's make a change in our index.ios.js file and change the title to Hello World. Don't worry about the rest of the file. We are going to learn more about all of that in the rest of this course. After I refresh the simulator, we can see our first code written for React Native. The application we are going to build isn't that feature-rich, but nicely shows off the different parts and techniques needed to learn the basics about developing an application with React Native. As you can see, it is a movie browser. The data fetched is from the iTunes Search API and initially displayed in a scrollable list view. We are also going to use some native components like the navigation bar on iOS or an iOS alert view when tapping on the button. There is also a custom search bar that actually hits the network after typing a few letters. It automatically fills the list view with the new data. The application also features a detail view, which uses the iOS navigation principles again and displays more details about a movie. In this view, you are going to learn a lot about layouting. Let's look at another movie. You can see it is rated PG-13, and here we are going to use custom styling and fonts. Of course, they are actually pre-installed on the device to display the content. We also have a button that, in theory, links to an external application. In the simulator, of course, the iTunes Store isn't installed, so it won't work here, but it does on the actual device. Code-wise, the start like media list view and media detail view, as well as media cell, and the styles directory and file. Everything else is created by the project generator and left as is. We aren't going to work with Android in this course, so those files are also unchanged, and everything with Android in the name shouldn't concern you for this course, as it will be ignored by the packager. The result of every lesson is tagged in the course repository, which you can visit through the link below. Let's get started by creating a new application. Like in the setup lesson, we are going to use React Native Init, and we call this app iTunes Browser. The initialization can take quite a bit, so just be patient. After this is done, let's begin by starting up Xcode, and for now, I will just run the simulator. As you can see, it will start the React packager, which is responsible for translating our JavaScript code into a format usable by the iOS application. It runs locally on port 8081, which means you can only have one React Native application running at a time. So, let's have a look at the iOS application itself. The project has only one class specific to the application, which is the app delegate. It is the main starting point for every iOS app. In here, in the application did finish launching method, is the path to the React packager server. You can also compile the code and bundle it up to provide it within the application, which is what you want to do when distributing it through the App Store. You can see that React Native uses a custom root view object, which takes care of initializing and creating the necessary native views from the JavaScript application. It also specifies the root module, iTunes Browser in our case, which holds our application. Now let's get to our actual application code. The main file is index.ios.js, which right now holds all the components we see on the screen. We also have some styles defined in line. Those work more or less like CSS styles. When I change the background, for example to red, it gets updated in the application. The file also exports our base component, which is iTunes Browser. To get started with the application, let's clear out everything we don't need right now. We are going to add those things back in once we need them. First, clean out the imports. For now, we only need app registry and view. Then also remove all the views from the component. And we also don't need any styles just yet. This is what our base class should look like at start. To explain a bit about the architecture of React and React Native, let me get some visual help. React and React Native are based on components. They are focused on the view layer of the application. In an iOS application, you will need to do everything else, like networking and data management, but you don't need to use the React framework to do it. You can use regular old, or rather new JavaScript. The React packager is capable of transpiling ECMAScript 6, which is a standard that has been ratified only in June 2015. It took about 6 years to move from version 5 to 6. For instance, you can use the fetch arrow you might be used to in CoffeeScript, which doesn't change scope of the this keyword. You can also now create classes and use promises. But back to React now. A React component is largely based around the render function. This is where the magic happens, and your component gets its structure and visual appearance. If you have ever read or watched something about iOS programming, you would say each component is like a view. Those components can use other components within the render methods, so you can easily stack them and put them together to create a hierarchy. Let's take our application for example. We are going to have a list view. It consists of many different components. For once, it has a number of cells. Those cells each have an image and some text. The text may also be wrapped within a view to help with alignment. All those parts are components. Some are provided by React Native, like view, image, or text, and some are created by yourself, like the list view cell, for example. For now, this is all you need to know to understand how a React or React Native application is built. I will explain the inner workings and other concepts as we progress through this course. As you can see, I've got our project here. The first thing I want to do is to enable live reload in the simulator. So every time we are going to make a change to our code and save the file, it will update the contents in the simulator. Let's get right into it by creating a navigation bar on the top. I'm creating another wrapper view in our main component and add some text components. One for the title and another one for a future button on the right. When I save the file, it will show an error that the text component isn't yet imported. It also suggests what to do right in the simulator. So we have to add the text module to our imports from React. After we do that, we can see that it renders just fine. But the two text views are rendered in the top, right underneath the status bar. This is because we have no style sheets yet. Let me quickly import the style sheet module and create a basic style sheet. We want to create a navbar, so let's use this as the name for our style. And add a background color and some padding. I will also set the flex direction to row, and you will see why in a minute. When I save, it changes the view, but right now everything is black. I'm going to import statusbar iOS, which is a native component, and set its style to light content. You don't have to worry about what the component does at all. I just wanted to have the status bar show in white. I'm also going to add some styles for the title and the button. I want a very light gray as the text color, a center aligned text, and a bold font. I'm also going to set a style for the button, adding a specific width and keeping the color and text alignment like in the title. Since I'm going to cover style sheets in the next lesson, I'm not going to explain everything I just did there. All that's left to do is to set the style on the components. That's better. Now we can actually see everything. Flexbox has the concept of a main axis and a cross axis. Right now, the main axis is set to row in our navbar, which means the items are aligned in a row, which is what we want in the navigation bar. If I'm going to change the main axis to column, it will align the items beneath each other. Main axis and cross axis are especially important for alignment. I'm going to only show an example right now, but will actually use alignment throughout the course and later lessons. You have two directions in which you can align items. When aligning along the main axis, you want to use justify content. If I'm setting this to center here, you can see that it will center the content within the parent view. If I change the main axis to column, you will see that it changes the behavior completely. It is still centered along the main axis, but since the available space on the main axis resizes with its content, it won't be visible. The other attribute you might want to set is Align Items. It works along the cross-axis. If I set this to center, it will distribute the available space of the cross-axis to center the objects. Next, we are going to cover resizing. You might not always want to only align items, but also resize them appropriately. In our case, we want to have the button stay the same size, which we already specified with the width attribute. And we want the title to fill the remaining space. This can be done by using flex 1 on the title. Doing so will have the desired effect. The flex attribute uses the value as a factor relative to other items within the same Flexbox container. Since the button doesn't have any flex value, which means it's 0, it won't resize. If I'm adding flex 1 to the button as well, you can see they resize to the same width. When I'm changing the value of the title to 2, you will see that this item is now twice as big as the button. Now, since I want the title to be centered in the navbar, I'm going to add a dummy view before the title with the style of button as well. The Flexbox Layout is a very powerful tool, but it would be useless if you couldn't mix and match it with different views. To demonstrate this, I'm going to add another view below our navbar and add some sample text. I also have to assign style classes to the main container and content views. The style for main container is very simple and only has a single attribute, flex1. You're going to see why this is important in a second. For the content, I'm going to set a background color to be able to actually see the size of the view. After saving, you can see that the content view ends after the text, which isn't what we want at all. We need to add flex1 to make it resize the way we want. You can also see that the navbar doesn't resize at all, but inherits its height from its content. You might also have noticed the default value of flex direction is column. In React Native, every view is Flexbox enabled and defaults to a column style layout. To demonstrate why we also needed to set flex1 on the main container, I'm going to remove it for a moment. Even though we set the flex factor on the content view, it only resizes to the space made available by the parent view, which is by default the full width for the view component and the height defined by its content. To make it fill the screen, we need to set this flex value. Throughout the course, we will make heavy use of Flexbox and nesting, using everything. To use styles, you have to create a style sheet by using the provided React class. When creating it, you can define style objects on the top level. Style sheets in React Native don't support inheritance. To use a style object on your component, you can set the style attribute and reference the object with dot syntax within curly braces. Curly braces in React are used to bind dynamic values to the output of your render function. We already did that in the last lesson as well. What I want to do first is to organize our styles a little bit into a global style sheet if you wish. To do that, I'm going to create a new file called styles.js. The header of the file is going to be the same as in our index file, but reduced to just importing the stylesheet class. I'm also going to export a new stylesheet as the default. Let me copy the contents of our stylesheet from the index file into a new styles.js file. I'm now going to require our new file in the index file. After saving, everything works as it did previously, which is a good sign. Now, having a single styles file isn't going to be a good solution for larger projects. As with modern web development, it is a good idea to split those files up. Let's create a new file called navbar.js in a new folder called styles. I will copy and paste the contents from our styles.js file and remove everything not related to the navbar. I'm also going to rename the navbar object to default and remove the prefixes on title and button. Or maybe even better, let's use appearance, which is more of an iOS style way. Let's also create a second file within the directory, which contains our global styles. I'm also going to paste the styles.js content and remove all the navbar specific style objects. In our styles.js file, we can now just use a hash to define different subcomponents from different files. In our case, global and navbar. As you can see on the right, when using auto reload, you might run into errors when you prematurely save some files, like I did right here, by not removing the closing bracket from the previous iteration of this file. When this happens, you'll most likely have to manually reload the simulator. Now, after we reload, we have no styles. This is due to the fact that we have to rename all the styles we use in our main component. After doing this, everything looks again as it should. Now on to some handy features of style sheets. For demonstration purposes, I'm going to create some component-specific styles inline, which is a common way to split between globally shared styles that you define your overall appearance in and styles specific to the component that is needed to properly define a layout. I'm going to create a style called title italic, which just has the property of font style italic. Now, I want to have the title look like it does right now, but additionally have it be in an italic style. We can do that by using an array for the style property. When doing it like so, both styles are going to be applied. If there are conflicting attributes, the rightmost style takes precedence. I'm going to show you this by adding a font weight of normal to the title italic style object. Since it was referenced after the navbar title style, it will override its font weight bold property. You can also use inline styles. It is not recommended to do so, since it creates a mess within your markup, and you can't reference and therefore reuse it. In my opinion, it is okay to use it if you only need to set a single attribute, like flex, and I will do so throughout the course. There is also an easy way to do conditional styling. The style property is very forgiving If an attribute is null, undefined, or false, it will simply be ignored. This means we can use simple Boolean operation to set a style sheet. For example, if we want a button to only show an active style when it is in fact active, we are going to check for the state and then use the button active class, which will be returned in this statement. Of course, we don't have any state or button yet, but it will come up later in this course. To know which style you can use in different components, you can look at the styles documentation of React Native. You also have a summary of what I just told you, and on the bottom you have links to the style attributes for different components, like view, text, where you have font style, font weight, etc., Flexbox styles, and so on. Now, before we finish with this lesson, I wanted to talk about resolution. When we look at our styles, you might have noticed that we didn't set any units, like it is common with normal CSS. The reason for that is that internally it uses points, but during rendering it converts them to pixels. Originally those were the same, but when the iPhone got a Retina display, it introduced high DPI to mobile applications. This made a huge difference if you used actual images in your views, but not so much when already rendering based on points, since the virtual size of a button didn't change, but the number of pixels it took to display it on the screen, the physical resolution, did. Now when you use a top padding of 30, it would translate 1:1 on the older devices, like the iPhone 3GS, but on newer devices, like the iPhones 4 to 6, it would translate 2:1, meaning the physical size is 60 pixels. On the iPhone 6S, it would even be a 90 pixels, since it got an even higher DPI screen. So essentially, using points gives us a coordinate system that is independent from the actual device resolution and the same on every device. Sometimes, though, you want to use resolution-specific styles. For instance, having a line be 2 or 3 pixels thick on high DPI screens would look really ugly, so you want to set it to 1 pixel regardless of the device. Due to the screen resolution of this recording, I can't actually show you the results of it, but there is the pixel ratio API you can use to dynamically calculate sizes based on the device that is currently running the app. There is also a reference list in the documentation of the pixel density for different devices. Another thing to note is that React Native automatically rounds pixel values to the nearest pixel. So if you calculate the position of a view on the fly and the values are between pixels, you won't have to manually round the values to avoid pixel interpolation. We created a custom toolbar with a view and some text fields. As a first action, we are going to replace this by a native component called Navigator iOS. It is the native iOS navigation controller that allows views being pushed onto a stack and which has an already predefined style by the system. First, we have to import it, and then we can copy the style attribute from the main container and add an initial route. This route is going to be our root view, which will be displayed when the navigation component is rendered for the first time. The only two things we need are a component class, which we call media list view for now, and a title, which I keep named iTunes browser as before. For right now, I'm going to define the new component in the same file and keep it very bare bone, so I have something here and there won't be any errors thrown by React Native. I will just return an empty view. There is an error thrown when I save right now, which shows an essential requirement for a component. There can only be a single root node for the component. If you have multiple things you want to display, you will have to wrap it in another view. So, let me delete the old content, and while I'm at it, let's also reuse the sample text in our new component. When there is an error, you most likely have to manually refresh the simulator. As you can see, there is the native component rendered like it would be in a native iOS application. Of course, now the status bar is messed up. But since those native components work quite differently in regards to styling, we will be fixing that in a moment. You might also notice that the content is below the navigation bar, which is not what we intended to do, but is the default behavior in iOS nowadays. To start styling, we are going to set some properties on the navigator component that have counterparts in UIKit. First, there is bar tint color, which essentially is the background color for the navigation bar. There is also title text color for setting the text color of the title field, and a tint color property, which is used for the buttons. You can also add some more properties to our initial route. Specifically, a right button title property, which will transform into a native bar button item in the navigation bar. Due to the fact that we set the tint color, it is going to be displayed in a pretty gray. When I'm commenting out the tint color property, it will have the default blue tint from iOS. Of course, you could also set the left button title, but normally in iOS, this side is for navigating back to the parent view in the navigation controller. Now, let's add some interaction to the search button, which currently isn't doing anything. I'm going to add a callback function for our initial route, which is set with the on-right button press property. Let's just display an iOS alert view, which says that we pressed the search button. I'm quickly going to import this alert iOS component, and now, when pressing the button, it shows an alert. Since we already achieved our goal for the lesson, creating some user interaction, let's clean up a bit before digging even deeper. I'm going to create a new file for a media list view, which is going to be important and much bigger in future lessons. We are going to start by writing the standard format for a component, importing React and the used components, and then create our class, which I just copied from the index file. Back inside index file, I can now change the media list view variable from being a React class to being an import of our new file. After saving, it looks exactly the same. Let's also clean up the rest of the code a little bit, like removing the style sheets. We can now switch to our media list view component and add a search bar. First, I'm going to create a new component in here, which is totally okay, since it is quite short and only used in this component. Let me create a wrapper view with some styling and add a text input with some parameters. I'm going to disable auto capitalization and correction, and I want a placeholder telling the user what to do here. I also want a style for the input component. For styling, let's reuse the navbar file, which we don't need anymore. Of course, this breaks the application, since the import in the styles file failed. Let me fix that right now and also rename navbar to list view and manually refresh the application. In the list view style, let's define a search bar and first give it a top margin of 64, which offsets the navigation bar. Add some padding and a flex direction of row for further use. I also want to center the items in the cross axis, which is vertically here, and use a white background color. For the input field, I want to set the font size to 15, make it resize, and also give it a height of 30, since it would default to 0. The search bar component is completed for now. We just have to use it in our list view. Now I only have to import the text input, refresh the simulator, and we got ourselves a search bar, where we can enter text. If the on-screen keyboard doesn't show up for you, you can use Command K to display it whenever you focus on a text field. To make the text field even more like a search bar, we can define some additional properties like return key type and enables return key automatically. This changes the return key to be labeled search and only enables it when there is some input. We can also pass properties between the search bar and our list view, which is essential for interaction. On the search bar, there is a callback called onEndEditing, which gets executed when the return key is pressed or the keyboard is dismissed. We can pass a so-called property. This is everything that was passed from the parent component to it. We can set the property in our main list view and define it as an inline function. I want to extract the content of the text field from the event that was passed, which can be done by reading from event.nativeEvent.text. For demonstration purposes, let's just display an alert view like before, with the search string as the message. I'm only going to need to import the alert iOS component here as well, and we're good to trying it out. When I enter, for example, Mockingjay, and press the return key, it displays our search string through the callback. Of course, the return key on a physical keyboard is equivalent to pressing the search button on the virtual one. Before I finish with the lesson, let's make the app a little bit prettier by setting the background color of the content view to the same very light gray we used for the text. I wanted to show you the API documentation. It isn't very complicated because you only have a single API endpoint, where you can provide a bunch of parameters to refine your query. there is only one required parameter, which is the search term. Technically, the country parameter is required as well, but it defaults to the US iTunes Store. Additionally, you have a lot of filters like the media type, or for each media type, even more fine-grained options. For instance, if you wanted to search only for media of type music and you only want to get back albums. Maybe you also don't want explicit content and only the first 10 most relevant results. The returned data will be in JSON format. Here I've got the result of a search for Mission Impossible movies. You will also get the result count in the root node and then have access to, for instance, the track name or preview URLs for covers. So, welcome back to our project. Let's get started by using our search bar to actually search for data. I first will set the API URL constant to our search URL. So we keep the project nice and tidy. I will also need a loading indicator hash and a sample results cache that contains the fetch data for recent queries. Right now, we don't need the search bar component, so let me just collapse that. What I want to do is to automatically start searching when the user stops typing for a certain amount of time. Therefore, I will need a timeout. But since the component could, in theory, be unmounted before the timeout function gets executed, I need to create a safeguard to prevent exceptions from being thrown. I can do that by using a mixin called React Timer Mixin. When I'm adding the mixin to the component, React will add the functions defined by the mixin to the component that is using it. With this technique, you can reuse behavior on your components while still keeping your code dry. First, I need to set an instance variable called timeout ID, which is the current timeout that will be executed. I'm going to use typed syntax here, which is a thing you can do in React Native. For more information on that, you might want to check out TypeScript. I'm going to use this style now and then, so you can see a little bit easier which values go into a function and which value type is going to be returned. Now we are going to remove the alert view and replace it with our search function. Before we start searching, we want to clear the current timeout and replace it with a new one that will call the search function with the current search string. The next thing we have to do is to write the search media function. It takes a query parameter, which is going to be a string. First, we need to set the timeout ID to null again, because we don't need it to be cleaned up by the mixin. Then, we are going to hit the cache for data from our query. If we get a cache hit, and there isn't any other search currently loading this exact query, we will for now return the data. Otherwise, we are going to start fetching it from the API. First, we set the loading indicator and clear out the cache data. Then, we can use the Fetch API, which is a working standard and supported by React Native by default. I'm going to put generating the query URL into a separate function. It will return the API URL plus a restriction to movies, and then we will encode the query. Otherwise, we are going to fetch data for Mission Impossible, which makes it a little bit easier during development. Okay, it seems I got a typo in the else statement. Let's fix that and reload. Alright, let's move on with the fetching. Fetch will return a promise. So let's first transform the result into JSON once the promise has been fulfilled. If we got an error, we are going to set the loading indicator for the query to false, and then the results cache to undefined. If there wasn't any error, we can also set the loading indicator to false, and then fill the cache with our response data. For now, let's just display an alert view with the results count. I know that currently this method isn't very consistent with its data processing, so why don't we also display an alert view telling us that we hit the cache up here? Let me just save that and search for minions. And I probably mistyped something again. Yes, it should be app URL. But now, when we do our search, it will execute and we will get 0 results back because I'm missing an equal sign in the query URL. Okay, now it should finally work fine. Before I run the query, I noticed that there is a missing space in the alert view. Let me just add that and search for minions again. Finally, we get 2 results back, which I happen to know is the correct number of items. Let's try searching for Mission Impossible, where we already know that there are 5 results. And that is what we get. When we search for minions again, the message is a little bit different, since it is hitting the cache now. Now we have this fancy timeout method, but currently it isn't of much use. We can remedy that by change the on and editing callback in the search bar to onChange. I'm also going to add another safeguard to the search media function. I'm going to extract the query URL into its own variable and check if it's actually present. Then I can change the if statement in the URL generation function to only use the search term if I have at least 3 letters typed. When I now start typing, you will immediately see a result, which is due to the fact that the timeout is far too short. I need to change that to about a second, so when I'm typing Mission Impossible in the search bar, it is going to wait until I finish typing and then start querying the API. Right now, when I remove the text from the search bar, it will still query some data, since I left the default in the URL generation. If I remove that and only type 2 letters, it won't start to search. If I'm adding a third one, it will return some results. We are now finished with the networking part of the project. Of course, it isn't much yet, since we didn't start displaying our results in the list view. I wanted to keep that in its own lesson, so stay tuned until we do that. For now, I wanted to change back the timeout to a smaller value, so when we actually have our list view, it will get updated more frequently as you type if you aren't a fast typer. We have a working search bar that is hitting the network after typing a search term. It would be nice, of course, to store the data that we got from our search function in the component state and also indicate whether we are loading data or not. Before we can use the state, we have to actually set it. This can be done by returning an initial state from the getInitialState function, which in our case is just a hash with different attributes. For now, we want to store an isLoading indicator, the current query string, and the current results data as an array. With that done, we need to adapt our search media function a little bit. Whenever we search for some media, we want to set the state to store the current query. We also want to store the results data there when we hit the cache. So let's get rid of the alert view and replace it with another call to set state. This time, setting the isLoading indicator to false, and then storing the cached results for query as our results data. If it's still loading, we are going to set the state of isLoading to true. For the actual fetching process, we want to set the state of isLoading to true before we start the network request. After we finish processing, we don't want to show an alert, but set the state to isLoading equals false, and the results data to the one we stored in our cache in the lines above. Of course, if there was an error, we have to set the isLoading state to false as well. Right now, the isLoading indicator has no function, but it would be nice if we could display an indication if there is currently a query in progress. To do that, we can add an iOS activity indicator to our search bar. This is again a native component. I'm going to set the animating property to this props isLoading, which we will pass from the media list view, and I'm also going to set the style to styles list view spinner. We have to import the activity indicator, of course, and then we can change the media list view to set the isLoading property on the search bar to the value of isLoading state. Whenever the state changes, it updates the property on the component, as you can see when I start typing in the search bar. Now to make it a bit prettier, I'm just going to add the style to our list view style sheet. When I'm now typing minions, it won't show, of course, because the results are already cached. So let's use Mission Impossible. It isn't pressed against the right side anymore. We also haven't used the results data state. This will be done in the next lesson. We are going to swap the stored object for a proper list view data source. But for now, it is quite alright because we already laid out the groundwork for it. This is the current state of our media list view. We have done all the networking parts and also created a state variable to hold our data source. To start off, we first need to actually use the list view data source. It is an object that holds the data for populating the list view and handles different accesses to use this content. We also use a very simple function to determine if a row has changed, which tells the list view to reload. Then we want to also use component did mount, which gets called after the component has been mounted from another component. I want to have some data already present when I refresh the application to make it easier during development. So I call search media with a hard-coded search term. I also want a helper method to set the data source. It will take the current data source and clone it with the new rows as its data. In the search media function, we have to wrap the results data everywhere we set it for our state variable. If we get an error, I'm going to set the data source to contain an empty array. Of course, this should be results data. And now it should refresh fine again. The last part is our render method. We have to use the list view component and set some parameters on it. First is the data source, which we take from our state, and then two methods to render our content. One is the render row, and the other is the render separator function, which will be inserted between rows. I also want to not automatically adjust content insets, which would add the additional offset to the list view so it wouldn't be stuck underneath the navigation bar. Since we did that with the search bar already, we don't need it. Finally, the keyboard should be dismissed when dragging. On to our rendering functions. Let's start with the render separator. It takes a section ID and a row ID, which can either be numbers or strings, and an indicator if an adjacent row is highlighted. We have to return a view, so I'm going to do that and give it a key to uniquely identify the component. It isn't really important here, but I thought you should know about the fact that you can actually do that. I also want to give it a style of listview.rowSeparator, and if an adjacent row is highlighted, the row separator highlighted style object. Let's quickly add the styles to our style sheet. I only want to set a background color of 10% black, with a height of 1 and a bit of an indentation left, so it looks like an Apple table view. Now on to our rendering function. For attributes, we have the media item as an object, section and row ID again, and then a highlight row function, which we can call if we want to tell the list view that the row got highlighted. Of course, we want to return a custom cell here, but for now, let's just add a text component and display the title so we can see if it actually works. It does. This is very simple, but the data is there and it renders the rows and separators. Before we get started on the cell, I want to add another separator between search bar and list view and use an inline style to remove the left margin. Our new class is going to be called Media Cell. Of course, we need the standard React imports. I already know what components I need to do this, so I'll be adding them right now. We need an image, a style sheet, text, touchable highlight, and the standard view. Let's create the class and add the render function. First, we want to wrap everything in a view. Inside goes a touchable highlight, which allows us to interact with the cell. It gets two parameters, which are going to be callback functions we are going to pass from our list view. Those are important for highlighting the cell. Inside, we want another wrapper view. This time, I'm going to use inline style sheets, since it is very specific to this cell. The container should have a flex direction of row, with center-aligned items, as well as a white background and a bit of padding. Inside the container, I want an image. It gets a source which can either be a data object or a hash with an URI property. I'm going to use the largest artwork URL. Of course, I'm also adding some styling. For the style object, I want to set a height of 80, a width of 60, as well as a right margin of 8. The image should also be resized to be completely contained within the image view. With that complete, let's get back to the render row function and change it to use the media cell. We can also set the onHighlight callback to use the highlight row function, as well as the onDehighlight callback, where we set the section and row to null. Those tell the list view if a cell got highlighted or not. Now we just need to import the media cell. It seems like I forgot to close the media cell component in the render function, so let's fix that quickly. And we also need to set the media property, of course, otherwise it wouldn't work. Perfect. Now the images of our Mission Impossible query gets rendered in the list view. But showing just the images isn't enough. We also want the movie title and some additional information. So let's jump back to the media cell and add another wrapper view, where I will put the text fields. This has to have a flex property of 1, of course, to resize properly. Within that, I'm going to create a text component for the media name. In our case, the movie title, and with this restriction to just a single line. Inside, I want to output the track name of the media property, or, if that isn't present, the name of the collection. This means that movie collections that will also show up in the search results will be shown as well, because those don't have a track name attribute. I also want some more information about the movies. I'm going to output the year of the release first. Here, I'm going to use a little trick. I'm going to use parseInt to process the release date. This attribute is formatted in ISO timestamp format, which means there are 4 digits for the year, a hyphen, 2 digits for the month, and so on. By using parseInt, the attribute gets passed up to the hyphen, omitting everything that comes after the first 4 digits. After the year, I want a nice M- as a separator, and then print either the long description or the artist name if there isn't a description available. As you can see on the right, it already looks quite nice, but we can use some styles to make it even prettier. For the media name, I want a font size of 16 and a slightly bolder font, as well as some margin on the button. For the media description, I want to set the size to 12 and a gray text color to make it less prominent. It should also resize. The year, however, should be displayed in bold. Now this looks great. As you can see, we have a fully functioning list view now that can be dragged and snaps back into place, like you are used to on iOS. We also have our touch highlight component that notifies our list view when a cell gets tapped. Let me do a quick search for Star Wars to demonstrate why I used conditionals for the title and description. It looks a bit different, but if we didn't do this, there would be no text at all. When we type a search term that has no content, it is just in an empty gray. To improve this, I'm going to add some components to the render function of the media list view. First, I'm going to cut the list view component and replace it with a content variable. I want to add a conditional that tests if the results data row count returns 0. We want to set the content to some value if it does. Otherwise, I want the content to be set to our list view component. So, what is this value going to be? Well, we can just create a simple view with some styling and display some text. We are also going to conditionally set this. If we are not loading, since we don't want to display information of the search result before we even have it, and we have a query string, then we want to say no movies found for, and then display the search term. Otherwise, if it isn't loading, we want to just have the text say no movies found. Let's try it out. If I add a search term, we receive no movies found for. And if I clear it out, it just shows no movies found. Now to make it also look good, I need to add some styling. I want to set a flex value of 1 to make it resize and display the background on the whole screen, which I set to white. I also want to center align the text. For the text, I want to give it some top margin and also set the text color to a medium gray. As you can see now, when we add some random letters, it will display in the middle of the screen. And if I enter a search term that produces results, the list view will show. When I start scrolling, you can also see the keyboard gets dismissed automatically, and you can find the scroll indicator on the right. Before we create the detail view, I want to change the search media function a little bit and be more restrictive about the data. The reason for that is that I don't want to use too many conditionals in the detail view, since it doesn't add any value to this lesson to have multiple types of movies, in our case collections, to be displayed appropriately. I'm going to do this by adding another then call to our promise, where I'm going to filter the items by only keeping them when the wrapper type isn't collection. Since we did that, we can remove some hierarchy in the following then callback by removing .results from the response data. When we now search for Star Wars, we don't get the collection at the top. The other thing we have to change in the list view is to add another callback to our media cell component, which I will call onSelect. It is going to be a call to a select media item function, which takes care of pushing a view onto the navigator stack. The navigator is present as a property automatically when you use the component with it. I'm going to just set media details as the title, because I'm going to display the title as the first item in the detail view anyways. For the component, I'm going to set it to media detail view. There is also another property I didn't talk about yet. It is parsProps, which takes any data you put in here and directly passes it to the component. So, let's import the file as media detail view, and before we save, let's actually create it. As always, we are going to write the standard React header, which includes all the components. I already know which ones I need, so I'm going to import them right now. You should have seen all of them but the scroll view in this course already. It provides a draggable view you can use to scroll down if your content is bigger than the screen size. For now, I am going to just return an empty view in the render function. After saving this and the list view file, we have successfully created and imported the detail view. To use it, we have to add another property to the touchable highlight component in the media cell. It is called onPress and should be calling the onSelect property. We can already try the functionality by just clicking on a movie. It pushes the view to the left and reveals the detail view. In the top left, you can see the back button. It has the name of iTunes Browser, the parent component, since there is enough space on the right. I also just noticed that the title of this view is missing, probably because I made a typo when pushing the component to the navigator stack. Of course, it shouldn't be this, it should be title. Now, we can also see the title when navigating to the detail view. All that is left now is to create our detail view. Before we get started on that, I wanted to quickly add another file to our style sheet for the detail view. Normally, I don't paste prepared code, but in this case, I'm going to make an exception. It isn't anything we haven't covered yet, and I reckon that you don't want to see me typing all the styles manually, which would take far too long and is just tedious. We have enough to do with the layout itself already. As you can see, it is just basic style sheets. I even reused some elements from the other styles. Now on to our detail view. I'm going to change the generic view we have here to a scroll view. I'm also going to add some styling for this content container. Of course, I have to import the styles. As I'm only going to use the detail view style sheet, I will limit our variable to contain just that, so we don't have to write styles.detailView every time. I could also have imported just the detail view style sheet file here, but I want my wrapping styles file to take care of organizing how to load all the different styles. Within the scroll view, we first want to display the movie title and limit it to 2 lines. To also not always have to call this props media item, I'm going to use a shortcut variable called item. Of course, I should put it into the render function for it to work. You can see our title being displayed properly, which tells us that the styles and the variable are working correctly. Next up is a wrapper view for the main content section, which will contain the cover artwork again. We also want to display some additional information beside it. I'm going to add another wrapper view and add a text component containing the genre name. Below it, I want to display the content advisory rating. Let's try it out. It looks good already. So, moving on. Below the image, I want to display the description in full. To properly separate it, I'm going to use a separator like we did in the list view, and then add a label that is telling the user that this is the description, followed by the actual description. Since we are fetching data from the iTunes Store, we also have access to pricing information. I want to display that below the genre and rating. Again, I'm going to use a separator and then display the buy price and rental price variables. Not all items have this data, so we are going to omit it when an item doesn't. For the buy price variable, I'm going to use the short-handed conditional syntax to determine if there is an HD price and normal price attribute present. If so, we will render a view. If not, we will set it to null, which will cause nothing to be rendered. The view itself is once again a wrapper. In the detail view, you can really see how layouting takes place using Flexbox. Everything gets organized in rows and columns, and within those components, other components get organized again. So, I got the HD and SD price rendered in the view. let's copy the variable and paste it as rental price as well. I just have to change the attributes. When we visit a movie's details, you can see that it looks a little bit messed up. This can happen if you forgot to wrap your content in another view or put it in the wrong place like I did here. It can easily happen, but luckily it's also easy to fix. Now the detail view looks really good. Finally, I want to add a button to the iTunes Store. Buttons in React Native are just touchable highlight components that are styled appropriately. To actually link to an external application, there is a component for iOS called Linking iOS. We can call OpenURL on it in the onPress callback with the track view URL attribute. Of course, we have to import it to use it. So let's visit the detail page and view the movie in iTunes. Whoops, it goes to Safari alright, but shows an error. This is due to the fact that the simulator has no iTunes Store app. But Apple's servers try to link you there because they think you are visiting the page with an iPhone. If you would try this on an actual device, it would work, of course. When you return back to your application with the quick link feature of iOS on the top left, you will be presented with the same state that you left your app in. Let me just bring it up right now. Here you have a few different debugging options. You can either debug with Chrome and Safari, which we will do in a second, or you can use the in-app inspector. I'm going to open that right now. First, I have to tap something to inspect it, like this image. On the bottom part of the simulator screen, you can see detailed information about the inspected component. First, you have the complete hierarchy, starting with the root component. Then you have the style attributes we gave it. And on the right side, a visual representation of its size, padding and margin. You can use the inspector for all components that you can select, like the title, the wrapper view in the cell, or the activity indicator, which is invisible right now. There is also a performance overview of how long every step of the loading and rendering took. You also have a performance monitor that shows the memory usage, rendered components, and the frame rate for the user interface and the JavaScript performance. The next possibility is to debug in Chrome, which will open a new tab in the browser. If you don't have the React developer tools, you will get a notification that you have to install them first. They are a simple browser extension. Let me just resize the window so we can see the application as well and open the Chrome Developer Console. Here you will see the same output that will be displayed in the Xcode log window. In the Sources tab, however, you can debug your code. You will get all the files that have been loaded from your project in the list on the left. Let's, for instance, say that we want to see which URL value the iTunes button has. We can open the media detail view file and add a breakpoint in the render function. When we go back to the list view and open a detail view again to initiate another render, it will stop at the breakpoint. You can see the complete call stack and all instance variables, like the item, where you can look at the track view URL. If you ever use the Chrome developer tools, you will find all the familiar options working with React Native as well. When we resume the execution of the application, it will continue rendering the detail view. Of course, there is also the option of using one of the most popular debugging methods. Just log everything. For example, if I want to get the iTunes URL displayed in the console, I can do so in the render function. When I visit the detail page again, it will print out the URL right in the Chrome console, and you can work your way through your application. You can, of course, also log items, which Chrome will parse and let you browse all of its attributes. For a really interactive output, you can also use console.dir. When you use it though, you will only see the output in Chrome. This was a brief overview of some debugging techniques you can use to solve problems that you might have in your applications.